All right. Good afternoon, all. Let's begin. Just confirm if you can see my screen.
Yes, sir.
Yes, we
Okay,
can.
thanks, Bonai. Right, let's begin. So, new module, complex numbers, not bad. Um, I would say it's slightly easier than the previous. It's just a matter of getting used to. It does apply a lot of the rules of standard algebra. Um, but yeah, that being said, let's commence. So what I want to show you, I'm sure you guys you remember this from your secondary school education, where we had the natural numbers, the whole numbers, the integers, the rational numbers, the real numbers, which consisted of all these over here. And if you recall, when you did something called the nature of roots, right, you'd find, depending what the discriminant was, you'd know whether it's falling into a certain category, it's a perfect square or not. Can I just ask someone, what is it, what's the difference between a rational and irrational numbers? And can you give me some examples of it? Just want to see if people have an understanding.
So isn't rational numbers even equal numbers and irrational numbers non-equal numbers, sir?
What do you mean by that? I mean,
Like,
equal
isn't
numbers, not
rational
equal.
numbers like, for instance, like 2, 4, 6, and irrational numbers like 5, 7, 9?
No, 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 no. No, that's like even in odd numbers. It's
Oh,
to do
even,
with it's to do with decimal places. One has recurring decimals, the other one has non-recurring. Like you can also express rational numbers as fractions, whereas irrational numbers you cannot express as fractions. Are you familiar with that?
okay, yes, sir.
Yeah, it's coming back about that. Like root 2 will give you um as a 0.707, like different types of where 1/3 will be 0.33333. So that's that. But that's okay. It's not a big deal. Just checking. There's another number system above the real numbers. And the real numbers contains all of these. I'm assuming we all know the individuals from here. We started with the natural numbers, the whole numbers we had zero. We then found the integers, and I'll make mention of what this actually looks like. But anyway, yeah. So before we begin, the main thing where I just want to recap on is something with quadratic equations, all right, which is forms part of this. We all know solving quadratic equations thus far. There are other methods, but these are the main three analytical ones. Is the method of factorization we all should be familiar with. Everyone's favorite, the quadratic formula, and also the completing the square, right? But in this case, all you have to worry about is essentially completing the square. So the quadratic formula. What I want to start off with is the following, right? So imagine us having that following quadratic equation. I think we're all familiar on how to substitute from here to here. What's your B, A, and C coefficient? We plug it in here. And once you do that, we should get two answers, which will be 3 and 2, which is both valid for this equation. We know we are right because as we plug this back in here, it should be equal to 0. But now, let me share my OneNote, and so we can begin the lecture. So what happens over time is that, where's my OneNote? Can't see it here. Okay. Is that was fine when we had rational and irrational numbers under the root, or that's the result of it. But what happens if we have a case like this? I'm going to bring out that case. Where is this case now? Okay. I'm assuming you can see my OneNote?
Yes, sir.
Yeah, okay, perfect. So now I'm going to start to solve this. I mean, we can solve it together, not a big deal. Always just standard quadratic equation, very powerful equation. So b squared minus 4ac, right? Divided by 2a. We then have to now substitute the respective coefficients. In this case, this will be a plus 4. I'm just making it immediately plus minus. Our b was negative 4, which obviously be plus 16 minus 4 times 1 times 20. Divide all of this by 2 times 1. Okay. So this will be plus 4. We have a plus minus. Over here, we have a 16 minus, what is that? Is it 80, right? And divide this by 2. This should be plus 4 plus minus 16. That'll be negative 64 divided by 2. Are we able to find a square root of a negative number?
No, sir.
No, sir. Is Corneille my only student? Are we all familiar with it? Is the square root, can we find a square root of a negative number?
No, sir.
Okay, cool. Thanks, Abelo. Luvuyo, Dylan, Olile. Okay, so this was the problem. This is where the mathematicians got stuck. Okay, this is not a doable thing. But what someone has discovered, and I'm not sure this is, sorry about that. What do we basically do? Yeah, right. It's plus or minus now. What we do, we take out the so-called root of negative 1. And I'm sure we're all familiar with breaking down roots. Is anyone familiar with what is root 2 times root 2? Can we all do that?
Yes, sir.
Okay, so what is root 2 times root 2?
It's going to be 2, sir.
Exactly. Okay. How people know this, right? So in a similar vein, we separate these two terms. And the reason why we're doing this over here is that we are able to get a real number over here. Okay. So they notice that they can just take out the root of negative. What they call that root of negative 1, and I will just, okay, let me first do this. So our one root will be 4 over 2, or like, let me do it like this. Root of negative 1, root 64. And of course, our other root will be 4 minus root that 64 over 2. Could have done this later. And what they did now, that root of negative 1, they call that a j. It's also called I, depending, right? Okay. So what that means is this guy over here. That's 4 over 2 plus j. And of course, root 64 is 8, right? 4 divided by 2
That's correct.
is 2 plus j4. Obviously, this would be plus minus j4 in totality. And this will be, my colleagues, is what we, as of current, call a complex number. What is important to note of a complex number, there's something called the real part and something called the imaginary part. So that over there is a complex number. I want to make, and what I want to say to you as well, a complex number is a two-dimensional number. It's not a one-dimensional number. Super important. That means wherever we require some form of two-dimensional mathematics, which is very common in engineering, we are able to use this maths. If you go to Electro N Tech 5, Electro Tech N6, anything electrical engineering involving AC currents, complex number is a math for that. You can even apply this math to your standard vectors. same thing, right? Vector math and this math is nearly on the same end, but they eventually move to different spectrums in terms of application. So this is what a complex number is. So what's important for now is just taking out the root of -1. I also want to show you the following, okay? And this will come to something called the Argand diagram eventually. So let me just get my ruler here. I'm not using my, okay, I'll just use this. Add, draw a line here. And then, okay. Like that, 90. Okay. So what we all know is that we started with 1, 2, 3, 4, 5. That's our natural numbers. We then eventually established something called 0. That is our whole numbers. We went to -1, -2, -3, -4. I hope you all get in the pattern. This will become our integers. The numbers then in between, will be the rational and irrational numbers. And then that is where we stopped. And then the next, all of that became the real numbers. So what I mean now, when we took it to the complex numbers, is that the real axis is deemed like the x-axis, which you're dealing with. And then the so-called y-axis, right, is the imaginary axis. So when you plot a complex number, and someone just mute him, mic, please, man. Or should I mute it for you? What is that? Yes, so when you plot a complex number, it won't be just a dot. You know what I mean? It'll look like some kind of vector where you have A plus J, B. This is your real part and that's your imaginary part. This will come a bit later. But I just thought I wanted to understand that when you talk about a complex number, it's not a one-dimensional number like on a straight line. It has two elements, a real part and an imaginary part. Okay. And again, this is very important math, especially for the electrical side, using tomorrow AC currents. So let's try one of those fundamental problems. I'm just going with the textbook over here. I want to give you another one, which is from another book, and I want you to find the roots of this particular. I want you to solve the quadratic and find the complex roots. This is the one. It's not from the direct textbook, but it's good practice for understanding. So let's do it. Yeah. Okay, just put it on here. Yeah. So I want you to solve this quadratic equation. Remember, you're going to end up with complex roots. That's your standard stuff. Does everyone get the objective?
Yes, sir.
Okay. Do it quickly. Then we'll move on to the next part.
It's not showing all of it, sir. It starts from plus 3x plus 5. The first letter didn't show.
Can I just quickly see that? Oh, sorry about that. I think it moved there. I appreciate. Oh, they do it in this book. I was wondering where it was. Okay. Okay, cool. There we are. I'm trying to go over the main points here. I'll fill in the blanks for the rest. So this is 2.4 basically. 2.14, yeah. Let me know when you're done. So we need to solve the complex roots. I'll put up the solution. Or just put up the answers. You guys can figure out the, unless everyone is lost. I want to show you what this graph actually looks like. Are you guys winning?
Yes, sir, I'm finished.
Okay. The rest of the house? Guys, there's no point in joining the session if you're not going to participate, solve problems. I'm just saying. Come watch me work. Okay, cool. Let me just quickly see what it looks like. Is it right? Plus 3x. Okay, let me. Is everyone complete with the problem? Nice done. The answer should look like this. It'll look like that, just like that over there. There you go.
Yes, sir.
Perfect. Yeah, if you got that, well done. Again, important part, there's a real part and imaginary part. Is there any questions on how to get to complete this one?
Sir,
Yes.
should I write my number in decimals or what? Or can I leave
It
it?
doesn't matter, man. It's just two different ways of expressing, yeah.
Okay.
In this case, well, it's a different book, man. So just I want to see if people have gotten that. So let me just see who else. So Sabelo, you're talking to me. There's Sam, Shigalata.
Yes, I'm
Alex.
also done. I'm also done. I'm also done.
Okay. Talk to me, guys. Yeah,
Sir,
perfect. Yes.
I've seen many question papers that uses I. It should be fine for us to use J in the.
Yes. So I'll tell you the reason why engineers don't use I, because we sometimes label I for current, man. Are you with me? So
Yes.
So J, we adopted engineers. It's the same thing. If you
Okay,
look
so
at the
we can
cassette,
use the J if they've got I in the question paper.
exactly. I'd say it's the same thing.
Yeah.
Exactly
Okay.
the same thing. I just that not to confuse, certain stuff we label. Because you actually use I as a form of current in
Yes.
solving AC currents. Yeah. So it's same thing. They will not mark you wrong for using I or J. It's impossible.
Okay.
So you use I, use J, same thing, as long as it's a real part and imaginary part. And then if you're wondering what the graph looks like for this particular thing, I'm gonna turn on the grafting software now. It's gonna show you to show that you'll notice that there's no real numbers, right, on this particular graph. Well, there is a real number, but what I want to say to you, doesn't cut the x-axis at all. That's what that graph looks like. In this case, the y is the imaginary axis over here. This is what that graph looks like. There's nothing happening there. So you might think that it cuts, but it's not the same as the standard, your standard functions. Okay. If you guys are able to do that, I'm not sure how common it is in the question papers, but it's a very important thing to go through. What I'm going to do now is move directly into the addition and subtraction. I want to get to the bare bones of all of this, and then revert back to the other thing. So the important definition to note now is j equals root minus 1. Similarly, another important definition here is this one. So we take this guy, we square both sides, right? And then what happens there? You end up with a j squared and you end up with a -1. Is everyone happy with this over here? The math
Yes.
that I just applied now? Okay.
Yeah.
I say yes. So these two are very important, right? And you will see why. So make sure you know this. I mean, if you know this one, then obviously this one is kind of self-explanatory. So just like normal numbers, in normal real numbers, we are able to conduct certain operations, right? Like adding, subtracting, dividing, multiplying. In fact, even raising to the power, like, exponents and things like that. We should be able to do with complex numbers. Otherwise, it's not a number. So I'm going to show you now what we're going to do. How do we add? How do we subtract? How do we multiply? And how do we divide? Doesn't make sense right now until you're actually applying it on circuits. And then it's a whole nother ballgame. But I mean, it's just you're extending your mathematical ability. Let's quickly go to the book and then we'll start on the adding. No? Okay. Let's quickly do that. So now we're going to add complex numbers. Right, so I'm going to paste it and then we'll begin. So this is adding. After adding, we'll do subtract quickly. After that, we do multiply. After that, we do divide. Then I'll go back again. So how do we add? Fairly simple. All we do is just group the real numbers and the imaginary numbers together. There's no other tricks besides that. It's kind of self-explanatory if you think about it. If I put it into algebraic terms, right? In general terms, this is what I mean. So imagine I had one. I'll do it over here. I had one complex number a plus jb, and then another complex number plus c plus jd, right? Let me just remove these brackets. And so let's say I want to add them. All we do, we add, we say a plus c, which is the real parts, plus, and then we add b plus d, which is the imaginary parts. That's it. It's like, remember back in grade 8 or 9, where people are grouping, you're grouping the like terms and not like terms, that kind of thing. Same concept over here. So for instance, let's do this. 1 is 2 plus j3 plus 4 plus j6. I simply add 2 and 4, which is 8. I simply add 3 and that is 9. Well done. You've added two complex numbers. It's really easy, right? 6.
2
Oh,
plus
my bad.
6.
Yeah. I'm multiplying. Sorry about that. 6 plus j9. Okay. Are we all content to that? Really easy. Do number 2 and number 3 for me. Yeah, there's not much to say there. Yeah, it's super easy. Just have to add them. Yeah. Then you do subtract, you move on. The quicker we get through the things, the more, advanced we can get.
I'm done, sir.
Perfect. I expect the speed of Konai with everyone. You should be that quick. It's easy. Can I have number 2's answer? Thank
So
you,
I got
Ben.
-2 plus j13.
Perfect. The other one?
-10 minus 10j.
-10 minus
Yeah.
10.
Yes.
Can we all corroborate Cornay's answers? Anyone? Bianca says yes.
Sorry, can I ask, say, if we're not, or as I'm far ahead of my head, are we not expanding by multiplying?
No, we're adding. We're just adding.
Oh, okay.
We're not. She's just adding two complex numbers, right? Remember, it's a number. It's just a number. And we need to find. We're just talking about ways to add complex. We're not yet at multiply and divide yet. As you can see, there's a big plus in the middle separating the two terms. I believe everyone is good with this. Are we all happy with this? Can I move on to subtracting quickly?
Yes, sir.
Perfect. So let's just look at subtracting. Subtracting is exactly the same. However, the case of signs always tends to trip people up. I'll just put that there. Come over here. So the same rules apply. The only difference is now, instead of having A plus JB, let me do it like this. In general terms here, now is a negative, but we do exactly the same thing, right? We're going to say A minus C, okay, and then B minus D, okay? So that's basically it. But the only challenge sometimes is that this could be a negative, so you're going to have to always say negative times a negative, which becomes a positive. I hope everyone's with me. So it's exactly the same. So let me do one. Let me do number 2. And you guys can do 2 more, right? So I'll do number 2. And number 2 is minus 6 minus J3 minus 4 plus minus J7. Okay. So as I said, we say minus 6. Shouldn't be minus 6 minus 4, right? Or you guys agree with that? Minus
Yes,
6
Yes, sir.
minus 4, right? Okay, so that's, let me write that out quickly. Minus 6 minus 4. Obviously, we know that that's going to be a plus. I'm just doing it a bit like this. Then we're going to have our j's over here. I'll just do it like this. We're going to have minus 3, right? You can put it, you can keep a plus here. So it's minus 3 minus, what is it? Minus 7, right? So this is where the trip out is normally the case. This should give me obviously negative 6 plus 4, right? Which gives me, that results in negative 2. Am I right? And the other guy would result in a plus 4. So J plus J4. Because minus 3 plus, you know what I mean? 7 will give you 4. We're all content with that. And you see how the signs work.
yes, sir. But why is the second one in the middle there by the J is a plus sign?
Where in the middle?
Yes, in the second equation.
You mean this over here?
Yes.
What I just done here is basically, you could have kept it negative or positive. It made no difference. You have noticed that this will still giving you a positive J4. I'll just use him to separate the two terms, man. Like maybe I could have just. So minus 3 plus that, right? That'll give you a positive 4.
Yes, sir.
So, you know what I mean? So, I mean, you could have legit kept it open and wait till the end and then just fold it up. I just wanted to separate them. I mean, you can, if you put a negative here, then this would have been positive 4, right?
Yes, sir.
And then wouldn't that make that negative J4? Is that correct?
Yes, sir. That's what I'm.
Yeah. But I think that's not like right, man. That's the thing. So yeah.
So,
Well,
so
listen, yes.
I don't know,
Let
but
me
I
just
find it easier to just rewrite it or write it after the minus, just to continue, finishing it off. Then it would be -6 minus J3, and then obviously it would be +4 plus J7, and then all the signs are correct, and then to the
yeah, I mean you can do that as well, -6 minus J3. You can make that +4, you know what I mean? Negative what? That's plus J7, right? That's what you mean, right? You just add them up like that. You can do that as well, definitely. Then that -6 and 2, what is it? It's -2, right? Negative J3 and a negative, you get J4. Yeah, that's perfectly fine as well. So can you guys do for me number 5? Let's do 3 and 5. Then we can move on.
I think I'm done with 5 already. It's 1 plus J4, if I'm correct.
1 plus J4, I'm not sure.
And then 3 is 6 minus 4J.
No, it's not. It's not. Check again. I'll check.
But-
Now, what's number 5?
I said number 3.
Yeah, I know, but the previous guy. Yeah.
I said 5, it's 1 plus J4.
No, it's not. It's 1 plus J6 apparently. I'm checking the answers now. Have a look. And then number 3 is 6 minus J9 apparently.
J9.
I'm just looking at the book. I haven't actually solved it myself.
So can I please ask,
Yes.
the question is 2 minus J3. Oh, and then it's 16. Oh, my bad. Okay.
Got
It's
it.
J16, yes, thank
Okay. Yeah.
Okay, no, so it's fine. That's not J10, that's J0 there by that bracket. Oh, so-
Yeah. Okay, that's perfect. Yeah. So it's super simple, man. I mean, you don't have to separate them like this, but you can do it straightforward. I mean, it's really up to you. Okay. Are we all happy with the adding, subtracting? I think the concept is fairly easy, right? It's something we're familiar with. Can we move on? Can we move on to subtraction?
Okay, all right.
Yes, sir.
Yes, sir.
Okay, perfect. I mean, multiplication. All right, so we've done adding, subtracting. That's fairly easy. And now we're going to end up doing the multiplying and dividing. So I'm just going to go with the book and show you exactly what it looks like. Then we'll solve some problems with this. Luckily for this, also very familiar to you. It's using standard algebra, the FOIL method, as they say. And here, over here, let me just quickly show you. This is not correct. This is supposed to be a multiplication sign in the middle here. I don't know what's going on over here, but let me do it in that terms for you. Let me just remove this and do it myself. So if I had A plus JB as one complex number and I'm multiplying by another one, C plus JD, we say A times C. Sure, we know this. We say A times that one, it'll be plus JAD. Then we say that times that, which will be JBC, and that times that, and we have J squared BD. And as I mentioned to you before, over here, this one, that J squared is also -1. So wherever you see a J squared here, right? Always remember that J squared is -1. It's a very important concept. You'll see it even in the next piece. So this will become a negative BD now, because that's -1. And that's JAD plus JBC. We then simply just group the real terms AC minus BD. You take out J as a common factor and you have AD plus BC. That's the general way of looking at it. Only key concept is this guy over here, because this prevails quite often, the J squared minus 1. So let me solve a problem and then you can do a few more. Okay. And you can do FOIL in any possible way. There's no standard way of doing FOIL. I mean, people start in different points, you know. It's maths. Maths, there's no one way to do something, as long as you get the right answer at the end. So let's quickly do this one. I'll do it for you, and you can do a few. So 3 plus J5, 7 plus J4. So 3 times 7, 21. 3 times that. Okay, let me be very teachy, you know. 3 times 7, 21. Plus 3 times, what's this? J4, which will give you J12, right? And then we're going to say, so we change that. That one times that one will give you plus J35. And then we say that one times that one will give us plus J squared. What is it? 20, right? Again, we just have to change this guy to negative 20. That's 21 plus J12 plus J35. 21, we can do it immediately. 21 minus 20 is 1. 12 plus 35 will give us 47. I believe that's a correct answer. Could we all follow this? Because it's fairly easy to do mathematically.
Yes.
Yes, sir.
Sure? You sure no questions? Because definitely in your up and coming assignment, it's going to be there. Are they sure? Is there any questions? Are you sure there's none?
Yes, sir.
Okay, perfect. Yeah. If you can do this, you're mostly ready.
Yeah. Just give the example, and then sorry, the question. We go through it.
Yeah, there you go. So let's do 2 and 5. Is that okay? Try that one. Let's do number 2 and number 5. After this, we can do division.
Okay, I'm done, sir.
Okay, cool. I'll put the answers now.
Sure.
I am very interested to see what people got for number 5. That is what I want to give the colleagues a moment. Yes, we know you in the class.
Four and 9 or number 5?
Excuse me?
Is it 4 and 9 for number 5?
What are you saying? I'm not with you.
Number 5 is the answer 4 and 9. Or am I mistaken?
I should give you one number.
Oh, yeah. Okay.
4 plus
13.
9. Yes, that's
13.
correct.
For number 5, is the answer 13?
Okay. Can I put up the answers?
Yes.
Yes,
Okay.
sir.
Perfect. Let's move. Let's see. Where are we? There you go. So your number 2 should be 3 plus J54. I hope you all got that. And then number 5 should be 13. Did we all get that?
Yes, sir. I got that.
Okay. What's very important is this one. All right. And what you notice is that when you plot multiplying a number by its so-called conjugate, I'm not sure if you guys are aware what a conjugate is. You talk about it now. It will make that a real number. It's a very important thing. Okay. If everyone got this, do you guys want to do one more of this, or can we move on? Can we move?
Yes, sir, we can move.
Yeah.
Perfect. Okay. So let me just revert to the book, and then we'll come back. So that particular thing at number 5 was very important. Yeah. So can you see my textbook?
Yes, sir.
Okay, cool. So now let's talk about this conjugate, right? And they're talking about this last 2 examples. Okay. They're saying, note that the 2 complex numbers are identical, just the signs are different, right? There's a -2, -J3, 2 plus J3. So they say what those pair are called, they're called the conjugate pair. Okay. And you don't have to be all too fancy with this, but the idea is to just know that a conjugate of a number, you're basically changing the sign in the middle. Its objective is to make that complex number into a real number. Okay, so just some examples of what the conjugates look like. If you had your complex number a plus jb, right, the conjugate will be minus jb. If you had 4 minus j5, you just change the sign in the middle, plus j5. If you have -2 plus j4, it would be -2 minus j4. If you're -3, -j7, you're simply going to change the sign in the middle. And when you multiply them together, you should get a real number. That's it. Okay, you understand why it's important. There is a nice shortcut as well for the conjugate pairs. And basically, they're showing over here this proof. If you take the one number and the other number, assuming you're taking z times its so-called conjugate pair, which they let z bar, it's simply a squared plus b squared. It's just a shortcut. You can do it, you know, the normal FOIL way, or you can just come straight to this. So it's entirely up to you. So this would be a bit efficient with the math. But anyway. So let's quickly illustrate. I'm not going to ask you to find conjugate pairs here. I think it's a bit childish. The reason why we must know conjugate is when we're dealing with division. So let me do one example showing you division, and then you guys can do maybe 2 or 1 more. Basically nearly at the end. It's very important for your next assessment to be able to do this. All right, let me show you. Okay. How do we find how do we divide 2 complex numbers? So we start with 3 plus j4. And then we divide by 2 minus j3. We then multiply. So what to first sort this out, the issue with this is that we have 2 imaginary numbers, and that is what we're not looking for. The reason why we're timesing by the so-called conjugate is so that we can get a real number at the denominator. So we can't put this in the standard a plus jb form, and that's the actual issue. So to get that right, we multiply by the denominator's conjugate on on both the numerator and the denominator. In this case, it's going to be 2 plus J3 and 2 plus J3. So I'll say that again, to make the denominator real, we are multiplying both numerator and denominator by the conjugate of the denominator. And of course, what you do to the bottom, you must do to the top. That's of critical importance. If you look at this properly, you'll notice it's a multiplication problem on the top, like this. So we're going to put in our FOIL. And then we have that 2 minus J3 and 2 plus J3. Like I said, there's a quick shortcut for this over here. I did show it to you now. So what I'll do, I'll quickly just do the top section for you. 3 times 2 is 6. 3 times 2 is 6. 3 times 3 is J9. That times that is plus J8. That times that is plus J squared. What is it? 12, right? And of course, if you know that shorthand, simply if you times a number by its conjugate, it's simply going to be 2 squared plus 3 squared, which will give you essentially 9. So let me just do that quickly instead of me proving that to you. It's 2 squared, and then of course I said minus. It's just 2 squared plus 3 squared, man, or negative 3 squared. Yeah. That's a shorthand I'm using, and you can obviously prove it to yourself. Plus negative 3 squared. Okay. Yeah, you can obviously do the standard. Like I said, if you have a number times its conjugate, you're always going to get some kind of real number. But this will come with practice, man. You'll see with experience. So then anyway, we must continue here. We know that this is going to be 6 plus J9 plus J8. This must become negative 12, right? Because of the J squared. We're then going to have 4 squared plus 9 squared, which will give us 13, I believe. I hope everyone is following so far. We then simply just add up the real numbers and the imaginary numbers. We should get a negative 6, I believe. And here we should have a J17. Okay? And divide that by 13. As you can see, we come into that standard form now. Then in the end, it's simply going to be negative. Sorry, man. This will be negative J13 plus J17 over 13. Then we got our A plus JB. And once you get here, you are done. A lot of students will stop at some certain points, somewhere. But you want to express the final form of a division as this. Is there any questions with this one before you do number 2?
No, sir, I'm good.
Okay. When I say just good, Heinrich, Mr. de Klerk, in the Pile, student 818. Okay, if that's fine, I want you guys to do number 2 for me. You quickly do that for me.
Please view the answer.
Sorry?
Please view the answer.
You want the answer for that one?
Yeah.
Okay. Let me the answer. Where's that one? I'll just put the answer there so long. Because now they're still figuring it out. Complex numbers is alright, man. Shouldn't be too bad. So the answer for number 5 is this over here.
So what should we do, number 5? So what?
Number 2. Sorry. I don't know what I'm saying number 5 for. The answer for this one is this one.
I need the answer of
Zusake, what are you saying?
I think he wants the answer for number 1, so
Number 1.
The number 1. Yes.
Oh, negative 6 over 13 plus j 17 over 13.
Okay.
Colleagues, if you're unsure, please ask where you went wrong.
I think you say it.
I'm struggling to hear you, Lusaki.
Yes.
Yes?
You ask me.
Okay, I can't hear this guy. Aspesh, are you winning there? PJ, CJ?
Yes, sir.
Okay. Let's see if we can get number 2. If we can get number 2, perfect.
Yes, so I got number 2, yeah.
Okay, perfect. CJ's got it as well. Okay,
Sir, I'm still confused by number 1.
that's fine. There we go. Okay, where are you confused with?
There where we timesing by 2 plus j3.
On top,
Yes, I think it's the second step.
this over here.
Yes.
So we're multiplying this to the you know the conjugate of this over here, right? What you do the top, you must do to the bottom.
Conjugate.
Yes. It comes in the case of division problems for complex numbers. And the reason why is that you want to get the final answer into this form here.
Oh, okay.
Okay. Are you with me?
Yes.
Yeah.
Gotcha.
So it's more of you're just learning something new, you know, it's nothing. How do I say? Yeah, complex. I can find this now. Colleagues, are you guys winning there?
So they will leave answers in decimal or just like this?
Fraction or decimal doesn't make a difference, yeah.
Yeah, we done this. So I'm done.
Okay, perfect. It's fairly easy, eh?
So
Okay.
I think that the test 2 will be challenging, so for the
Yeah,
game.
definitely it's gonna be. Yeah. Now this is all right. I can assure you. I'm gonna do one more thing, and then the other two will continue with the others. And I can continue the next section as well, but let me just go back to. I'm going back to the start now, and it's to do with the J squared stuff. I want to go over it quickly. I'll show you what I mean. Yeah. So that's in a nutshell. Yeah. But like you said, test 2 will definitely be the tough one. That's why I didn't understand the panic of all these students. But anyway. But the key is to put in the work. Yeah. All right. So as I did explain before about I'm coming back to the simplifying the powers of imaginary unit J. This is like an add-on section. But I did talk about J equals being root of -1. And if you square both sides, you find that J squared is equal to -1. And if you want to find J cubed, which will be J squared times J, right? We know that J squared is -1, so therefore -1 times J is -J. If you want to find J4, that'll be 2 J squareds, therefore that'll be 1, right? If you want to find J5, that'll be basically J4 times a J. And J is, or you can have it like this. You'll find out J squared times, or J4 is basically 1. There will be J. J25, going to make J squared to the power 12 times by J, and you get J. So what I'm trying to show you here, and what I like what they're saying here, is that for powers of -1, right? Or having an odd index, you end up with a -1. If you have -1 with an even index, you have a +1. But the way I always remember, if I know what my J squared is, J3, J4, to find higher numbers, it's a lot easier. So I'm just quickly show you something here. I just want to come to these problems over here. Once we do these ones, then we're basically done. Just these powers of J. Yeah. So I'll just go back there. I do see it up here in the question papers as well. So yeah, it's not tough, man. You gotta just know what to do. So I'm placing it here. I'm assuming you can see my OneNote. So like if you do 1.1, like I said, it's the 1J8. But you always want to just work it yourself through. You start with J squared being -1. Obviously, you know where this comes from. And if you want J3 is simply J squared times another J. But you know that J squared is -1, so therefore this must be -J, right? J to the power 4, in this case, it's going to be J to the power 2 times J to the power 2. You know that J2 is equal to -1, so -1 times -1 should be 1. Okay? So J to the power 8 is simply 2J4s. These are not so colleagues. Are you with me? Am I right? Laws of
Yes, sir.
exponents. Yeah, that's straightforward. You could have even broken this up to J2, J6, J5, J3. You'd come out to the same answer. So J4 will be 1. J4 will also be 1. Therefore, J8 is 1. That's it. I'll do 1.2 for you. And you guys can play around the other two now. J9 is simple. It'll just be a J3. Is it? It's 3 J3s, right? Because we're adding the exponents. And in that case, J3, 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 this would be a -J times another -J times another -J. We know that -J times -J is +J squared, which is -1, right? This over here is -1, according to that. Then that's a -J. That times that will basically give us a +J. So it's just an algebra play around. This has absolutely no real significance, honestly. It's just a mathematical game. So what you guys should try is 1.3 and 1.4. Now remember, you want to break it down to terms that you're aware of. For 35, you just got to be smart about how you break this up. 12 could be 4 and 3. You have many options. Could be try number 1.3 and 1.4. You have many options. But normally try to work with J squared. It's the easiest one. Yeah. And then you're done. You're done with me. Is there any questions? Or if you're unsure with this? Guys, talk. Don't be shy.
So can I please ask what's the answer?
Just me doing it. We could say
It's the same.
it's J4 times J3, right? No. We could say what is 12? 12 could be J squared to the power 6. Can we do that? Right? Yeah, 6 times 12, right? And that'll be -1 times to the power 6. Can we do that? That's a positive index. If that's a positive index, therefore you end up with 1. It should be 1, right? So you get
Yes,
1.
that's what I said. It should be the same as that of J9.
Yeah, exactly. It's 1. Try the next one. And that's what I meant by that powers. I'll put it up here. Yeah. So yeah, I always try to work with the J squared, which is a lot easier. We know it's -1 and we know 1. Yeah. We can try 1.4, which is 35. We can do 7. There's many ways to do that one. So you see what I mean here? -1 with an odd index will give you a negative number. If -1 with an even index will give you a positive number. I mean, that's, if you know your math, yeah, it should be all right. So I kind of stick to that. So J35, we could go J squared and then 17, right? Can we do that? If you're using this over here. Always work with the J squared, it's just so easy. You could do J cubed, you could do J4. It's entirely up to you. Okay. Colleagues, are we winning? If you're unsure, please ask. Organize. Please engage and ask.
Okay, so I'm done with 1.4, sir.
Okay, perfect. What did you get?
I got minus
Negative
J.
J.
Negative J, eh? Yeah, I agree with that because if you did it, yeah, it's definitely negative J for sure. That's a negative index there. Yeah. We all get
Can you
negative J?
explain that one to us, man?
We'll explain on 1.4 for you.
Yes, because I'm a bit confused.
No
Yes,
problem.
please. Yes, please.
So like I said, what do you want to do? And by the way, with maths, guys, there's not one way to do something, you know, and I'm so constrained with time with these things, but I mean, yeah. The J35, you could go, like I said, J squared. The reason why I choose J squared, because I know it's -1 already, right? I make that to the power 17 times what? What's this?
It's not 17 because 2 times 17 is 34, not 35.
Oh, okay, no, that's fine. That's fine.
It's gonna be
17 is fine. No, it's fine. It's 34. Then you have another J over there. You see what I mean?
another
Are
J.
you with me? Are you guys with me? So that's 34 times
Okay.
J. 34. Yeah, yeah. So like again, I come here -1 power 17. And then like I said over here, if it's an odd number, you know, if you've done this with experience, you know that this will give you a -1, is it not? You know what I mean? -1 to the power 17, you can even check in a calculator. You end up with -1, you end up with a J, you times that and that, you get negative J. That's it. Game over.
Okay, good.
You got it. So just being smart on the way you want to deal with it. There's many ways. You can even extend all of this to J5, but you'll pick up a pattern. When you go into J5, there's many alternatives on how you can do this. But I don't want to, yeah. Okay, guys, we're basically at the end for my shift here. I hope you guys learned something. Other tutors will take over. I just want to show you something as well. Yeah, you know, let me just end off with what I always show you guys some interesting stuff, I believe. And we pull up at Ocasio. I'm gonna show you two things and then I'm done with you. All right, Casio's over here. I want to verify my answers. I'll go to mode. I'll go to complex over here. All right. And when I'm in complex mode, I'm able to compute complex operations. So let me show you. All right. Let me begin with some random one over here in the book. I'm assuming you can see in the book and the calculator. Can you?
Yes, sir.
Yes, sir.
Okay, cool. So like, yeah, let me add the number 1. All right. So I'll open a bracket. I'll say, what's it? 2 plus 3. And instead of a J, we have an I now. We just press the I. Always make sure the I is after the number. Repeat that. Make sure the I is after the number. Plus 4 plus 6I. Right? Close the bracket and equal. 6 plus 9J or 9I. Well done. Very simple, right? Okay. Moving on. You guys are always quiet when I do this, you know. I always get worried. Let me look at
Now we're looking, listening.
let me look at number 5 over here. Open 2 brackets. I say 4 plus. You don't have to put the J0, but I'll do it for you anyway. Because it's just J0 means it's just 4 minus, right? Again, calculate just for verification purpose, 6i. Close the bracket. We figure the answer of 1 minus J. You know what I mean? Confirmed.
Yes.
Move on. Let me do a multiplication problem. Right? Let's do number 4 over here, right? Open bracket. 2 plus I 0i, right? Minus 3, number 4 over here, plus 7i. Always make sure the I is on the right hand side. Beautiful, right? There we go. You see there? Let me do a division problem. Let's find one here in the exercises. Like that one, number 1 over there. 1 minus I. And then 2 plus 5i equal. There's your answer. What do you think of that?
Sorry, sir.
Yes.
So is this calculated just to verify your answer? Since the question is like 3 marks, so you need to do all those steps and then use the calculation just to verify.
You don't have to use this calculator. What I'm showing you is just me showing you something that I know. Are you with me, DPLA?
Yes, sir, that's cool.
Yeah, so at the end of the day, you still have to present your analytical solution. I'm just giving you peace of mind. That's all. You know what I mean?
Yes, sir.
Yes, Brent.
So can I ask a question about test 1?
What is it?
Will we be doing it rectangular form or rectangular, what do you call it, to polar form? Or,
You're doing the whole module 2. Everything.
so we can take that in module 2.
Yeah, everything.
Yeah.
Yeah. So you should have been there by now. Yeah.
Yeah, I am there, sir. And then the other question is, sir, since you are not done with us, who's the next tutor that we must?
Don't worry. You'll come in the group, man. You'll see. Don't worry.
Yeah, because the tutors, they take their own time, so that's why I'm asking.
Oh. No, they don't take their own time, man. That isn't the case. It's some Northlink not sorting stuff out. The administration. Yeah. It's not on my group of tutors, I mean, I'm always very active, but anyway. So also if you are there, you can also convert this into your polar form. And if you have this particular calculator, you can go shift, complex, and you'll notice over there, there's that thing of the R times theta, and you press equal, and you're able to get your polar form as well. Just by the way. You must be careful with these angles over here, because it will give you a negative angle sometime. So you have the options. Then I'll end off here. Just to show you what numbers, complex numbers look like, and this is where the next tutor is going to come in on the Argand diagram. It's fairly easy, but assuming I have 2 complex numbers, let me just define this one a bit better in the positive quadrant. Over here. I want C to be positive. So yeah, if I have 2 complex numbers, and you can view this as 2 vectors or whatever, right? If I want to find the addition of Z1 and Z2, right? And now I need to look at this thing here. What's Amazon talking about here? You notice that there's a real number axis on the side here, and your imaginary axis. And if I want to add them, the total want to look like that. Let me kind of shift this over here and just make this bigger. You can see there, right? Okay. If I subtract them, so if I add the 2 numbers, its total will look like that. Just make this big. Here we go. It's not what I want, but anyway. You know, I can't move that all of a sudden. There we go. Just zoom in here for you. Yeah, I just want to show you. Hey, man, come on. Okay. So you'll do the Argand diagram and you'll notice these things here. Okay. Anyway, so with complex numbers, it's not straight numbers. The numbers have two dimensions, and I think that's the point I'm trying to make here. Zoom in. Let's see what's happening here. Okay. So yeah, just for some reason I'm not winning with this thing. Okay. But yeah, so the Argand diagram, you have two dimensions, and it's not on the number line. It comes out as a vector. And let me just, I'm not using a mouse, and this is no problem. Okay, anyway, yeah, so that's fine. I'm not going to still waste my time here. But anyway, yeah, guys, so that's it for my session. Just can move this over here. I will only engage with you probably once or twice, depending. Also, if you in my strengths group, that's where I'll be engaging the other students now. And yeah, all the best for the up and coming assignment. Don't think it's going to be tough. As long as you've completed module 1, module 2, you should be fine. All right, guys, all the best.
So before you go,
Yeah, thanks, sir.
Yes.
sir, there's this thing of complex numbers in division standard form, right? Can I ask the condition there?